Section 2.6 is proving angles congruent. We're going to do some more proofs. So let's see. Theorem 2.1 is the vertical angles theorem. Now a theorem is a little different than a postulate. A postulate is something we accept as true based on definition. A theorem is something that we have to first prove, but then we can use it over and over without proving it each time. So our first theorem is vertical angles theorem. And it says that vertical angles are congruent. In other words, in this illustration, angle 1 and 3, since their vertical angles are congruent, and 2 and 4, since they are vertical angles, are also congruent to each other. So let's do the proof of this. Proof of theorem 2.1, vertical angles theorem, the fact that vertical angles are congruent. Again, let me redraw the illustration. If it's close to where you were in your notes, you don't have to redraw everything. So 1, 3, 2, and 4 is what we have. And we are given the fact by the diagram that angle 1 and angle 3 are vertical angles. And I could do this with angles, I could do this with angles 2 and 4 as well. Vertical angles. What we want to do is we want to prove that angle 1 is congruent to angle 3. Okay, so let's start our proof. Our first statement always has to be our given. So I'm going to write 1 as angle 1 and angle 3 are vertical angles. My reason is given. Second thing I'm going to say is that angle 1 and angle 2 are supplementary. And the same thing holds true for angle 3 and angle 2. And I can say that by the reason that angles that form a linear pair are supplementary. Okay? Number 3. I'm going to use my definition of supplementary angles. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. And I should really write it under the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And that is by the sum of the measures of supplementary angles equals 180. Okay, now, since this is equal to 180 and this is equal to 180, I can say that my first statement equals my second statement. And that's our transitive property. Property of equality. And number 5, I'm going to subtract the measure of angle 2 from both sides. So the measure of angle 1 equals the measure of angle 3. That's by the subtraction property of equality. And finally, I'm going to therefore say that angle 1 is congruent to angle 3, and that's by the fact that angles with the same measure are congruent. So from this point forward, we can use the vertical angle theorem without having to prove it each time. Anytime we see angles that are vertical angles, meaning they have the same vertex and they're made up of opposite rays, we can know that they are equal to each other. So how useful is that? So we can use the vertical angle theorem to solve something like this. Go back. So if I have a diagram with vertical angles, I can say that 2x plus 21 and 4x, these two angles, are congruent. Therefore, I can say that 2x plus 21 equals 4x. Subtract 2x from both sides, and x equals 21 halves. So I can solve for x pretty quickly by the fact that I know that these two angles have to equal each other because they are vertical angles. And I don't have to prove it, I can just use that information. Okay. There's another way I can use the vertical angle theorem, so I'm going to continue to use that. If I have been given some information, let's say I've been given that angle 1 is congruent to angle 4, and I want to prove that angle 2 is congruent to angle 3, and I give you this diagram. 1, 2, 3, 4. Now you notice that the given angle 1 and angle 4 are not vertical angles. And the proof that I want to do, 2 and 3, are not vertical angles. But using the vertical angle theorem, I can complete this proof. So think for a minute to yourself, how could I prove that if 1 and 4 are congruent, that 2 and 3 are also congruent? All right, let's see how we do. Let me get a different color ink here. Okay, so my statements and my reasons. So the first thing I'm going to say is my given information, angle 1 is congruent to angle 4. That is my given. My second statement is that angle 4 is congruent with angle 2. And that's by my vertical angle theorem. And that's all I have to write. I don't have to do all of the other stuff because I've already proven this. So, or I could say vertical angles are congruent. I could put either one down for my reason. 3, if 1 is congruent to 4 and 4 is congruent to 2, can I say that angle 1 is congruent to angle 2? Sure, that's the transitive property. 4, I'm going to say that angle 1 is congruent to angle 3. And that's the same reason as I put in 2. I'm going to write it a little bit differently. I'm going to write vertical angles are congruent. Those are the same reason, just stated a little different way. All right, and then 5, I'm going to use transitive property again. If 1 is congruent to 2, oops, what did I do? That's the transitive property. Vertical angles, yeah, so if 1 is congruent to 2 and 1 is also congruent to 3, then angle 2 must be congruent to angle 3, and that again is the transitive property. So I have given my proof using the vertical angle theorem and the other properties that we've already done. Okay, one more to look at. Theorem 2, congruent supplements theorem. This says if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So let me show you that. I hope that you're pausing to write because I'm obviously not pausing for you, so you need to do this on your own. So there are two angles, 1 and 2. Oh, wait, we're supposed to be doing supplements. Oh, I'm sorry. Back it up. Just change the word complement to supplement, because that's what I wanted to do first. So if two angles are supplements of the same angle, or of congruent angles, then the two angles are congruent. So let's do an angle here, and I want two angles that are supplements. So angle 1 would be a supplement, and angle 2 would also be a supplement. So what I'm saying is that if angle 1 and angle 3 are supplements, and if angle 2 and angle 3 are supplements, then angle 1 is congruent to angle 2. That's what our theorem says. Now, what I'd like you to do is to do a proof of this on your own. See if you can prove, given the fact that angle 1 and 3 are supplements, and also given that angle 2 and 3 are supplements, see if you can prove that 1 is congruent to 2. And we will do that in class together as well. Two other theorems that I just want you to write down. This is the first one. So if two angles are complements, so let's say we have an angle 3 here, and then I have a complement 90 degrees and another complement, then 1 and 2 are congruent. So again, if angle 1 and angle 3 are complements, and angle 2 and angle 3 are complements, then angle 1 is congruent with angle 2. We're not going to prove that one. We're going to accept that theorem. And we have one more theorem. Two more. Theorem 2-4, all right angles are congruent. So if angle 1 and angle 2 are both right angles, then angle 1 is congruent to angle 2. And the last one, if two angles are congruent and supplementary, then each one is a right angle. So in other words, if angle 1 is congruent to angle 2, and angle 1 and angle 2 are supplements, then the measure of angle 1 equals the measure of angle 2, which equals 90 degrees. So take a look at those last couple of theorems, see if they make sense to you. If they don't, we'll go over them in class. Try that one proof I asked you to do, and we'll go over that in class. And that's it for today.